Okay, final one we're going to do is limit comparison. And Szucs does his limit comparison when I look at his test keys. Kind of different than anything else I've seen. So we're going to try and replicate his way as close as possible because I know he can get picky if it's not done the way that it was taught in class. So the limit comparison that we have is, he wants to know that if we take the question, and you guys will have it, is infinity to n equals 2, and it's square root of n over n squared minus n square root of n. Alright, so big thing that we want to do first with a limit comparison is we want to look at what the highest power of x is in the numerator and denominator. So the highest power of x in the numerator is n to the 1/2, and the highest power in the denominator is n squared. What we do is we now solve for this. So that's 1 over n to the 3/2. In your book, if you look at page 598 at the definition number 1, you see something called a p-series. And what a p-series is if you have 1 over n and the exponent here, which they refer to as p, if that's greater than 1, then that's convergent. So I would make a note of that on your test. Now what Szucs does is he does limit as n approaches infinity for a limit comparison, and he puts this on top, so that's n to the 1/2 over n squared minus n to the 3/2. And then he goes one, let me look at his key, make sure I'm writing it exactly how he does. Then he does, so you're good through here, n to the 3/2, and then he does 1 over n to the 3/2. Okay. Alright, so there we go. I just had to make sure I wrote it a little bit different, but this is still the process that he went through. So 1 over n to the 3/2. So if we simplify this, probably an easier way to look at this, remember that A, B, C, D rule, how we flip it and we do A over B times D over C. So I'm going to have n to the 1/2 over, doing a test review session right now and posting it.
Are you getting the internet?
What? Yeah.
Is it resonant?
No, 3G.
Oh.
Okay, so if it's n to the 1/2, I'm going to have, that's going to be times the n to the 3/2 times n to the 3/2, and then it's going to be over the n squared minus n. So this is going to combine, and that's going to give me n squared over n squared minus n. I lost the limit as n approaches infinity over here, but you guys can fill that in. So to conclude things, when I do limit as n approaches infinity, I get n squared over n squared minus n. And remember, with limits approach infinity, I look at the leading coefficients. So I got 1 over 1. So that's going to equal 1. And I know if you get a finite out of it, it's going to be convergent. And I don't know if it has to be finite and positive. Szucs has finite positive written down here. I guess it's something worth asking him if it has to be positive as well. But if you get finite, and I believe it's finite and positive, then it's convergent. If you get anything else, then it's divergent. So to recap what we did, I figured out of this original expression what the highest power of n was in each one. and this one was n to the 1/2, and this one was n squared. So then I simplify that out, and I got 1 over n to the 3/2. This is called the p-series, and that p-series is on page 598. And if this is greater than 1, or if p is greater than 1, then it's convergent. And the idea is that if you divide something by the convergent and you get the finite, then it's going to be convergent as well. So I go and I divide whatever I got out of this by the original. I did that ABCD rule, and I ended up with n to the 1/2 times this. I got this term. I applied the limit as n approaches infinity. I got a finite positive number, and if I get a finite positive number, it's convergent. Same process every time, and what you're looking for at the end is whether you get that finite positive number. Make sure with Szucs that it is finite positive. I don't know if it's just finite as well would work. That's going to wrap up the concepts that we didn't cover that other day in the test review. And work with each other, and the Paul's online math notes are a great resource to use. And if you go on the desktop where we do our work, I should have the test scan in there by tomorrow. Definitely by midday tomorrow. It all depends on whether the library's still open by the time I finish the test reviews for all the other classes. Alright, good luck guys.